Hello there, what's up, amazing people and all students and lovers of chemistry out there. I'm back with yet another banger on this series of balancing redox reactions. So we have this question on the screen right now, and we've been asked to balance this in the acidic medium. So let's go ahead and treat this bad boy. First of all, we know that the rules for balancing redox reactions in the acidic medium. We've seen the rules earlier on, and the first step is to split this into the oxidation and the reduction halves. So let's do that real quickly. For the first half, we have Fe² plus yielding Fe³ plus. And for the second half, we have Cr₂O₇² minus yielding Cr3 plus. So our next option is to find out which part is the oxidation part and which part is the reduction part. So for the first half, we have Fe2 plus giving Fe3 plus. Now at this point, we want to find out which part is oxidation and which part is reduction. Now the oxidation number of ion here is +2. You can see it, +2. And the oxidation number of ion here is +3. So when something moves from +2 to +3, it is known that it has increased. And when oxidation number increases, we know that it is oxidation that has taken place. So this becomes our oxidation half automatically, our oxidation half. So automatically this other part becomes our reduction half. But I don't want you to take my word for it, okay? Let's go ahead and check first so we'll know that it is reduction indeed. So we have Cr₂O₇, 2 minus, and then Cr3 plus. Now the oxidation number of chromium here, let's find out what it is. So we don't know what it is, so we name it X. And then we have 2 atoms of chromium over here. That becomes X times 2 plus. Over here you can see oxygen, and oxygen has the oxidation number of -2 in compounds times the number of atoms of oxygen we have, which is 7. Everything is equal to -2, which is the overall charge here. So we have 2x plus -2 multiplied by 7 gives us -14, all equal to -2. So we have 2x minus 14 equal to -2. 2x is equal to -2 plus 14. X is equal to, or 2x rather, is equal to -2 plus 14 gives us +12. So therefore, x is now equal to 12 divided by 2. X is equal to +6. So the oxidation number of chromium here is +6. The oxidation number of chromium here, however, is +3. So when something goes from +6 to +3, does it reduce or does it increase? Of course, it reduces. So automatically this becomes our reduction half and this becomes our oxidation half. So the next step now is to go ahead and balance all the other atoms apart from oxygen and hydrogen. Let's do that. All right, now, so we want to balance all the other atoms apart from oxygen and hydrogen. For the first half, we have Fe2 plus yielding Fe3 plus. There is no any other atom apart from oxygen and hydrogen, just ion on both sides, and they are both balanced, 1 atom apiece. So the other half says Cr₂O₇, 2 minus, yielding Cr3 plus. On this first side, we have just 1 atom of chromium. On this other side, however, we have 2 atoms of chromium. So that means we need to put a coefficient of 2 over here to make chromium to be balanced. So the first equation becomes Fe2 plus yielding Fe3 plus. And the second equation becomes Cr₂O₇, 2 minus, yielding 2Cr3 plus. So you can see how this was done. So now, so the next thing to do is to balance oxygen atoms using H2O. Balance oxygen atoms using H2 and balance hydrogen atoms using hydrogen ions or H+. So for the first half of the reaction, we have Fe2 plus yielding Fe3 plus. There is no oxygen atom here or hydrogen atom here, so we leave it just the way it is because this step has been carried out in this half of the entire reaction. On the other equation, however, we have Cr₂O₇ 2 minus, giving us 2Cr3 plus. Now, the instruction says balance oxygen atoms using H2O and balance hydrogen atoms using H plus. Now, over here, you can see we have 7 atoms of oxygen, which means we need to add 7 molecules of water to balance oxygen atoms so that they are 7, 7 on both sides. Now that we have balanced oxygen atoms, you can see that we now have hydrogen atoms on the right hand side. How many hydrogen atoms do we have? 7 times 2, which gives us 14. Over here, we do not have any hydrogen atoms. So that means we need to add 7 or 14 hydrogen ions to the other side in order to balance hydrogen atoms. I'm sure you're seeing how this was done. So now that we have balanced hydrogen and oxygen, the next rule says to balance charges on both sides by adding electrons. So let's do that real quickly. So at this point now we want to balance charges in both half reactions. So for the first half we have Fe2 plus yielding Fe3 plus. Now, to balance charges simply means to add electrons, E minus, to the side that is more positive so that the charges on both sides can be equal. Now, here is what I mean. On the left-hand side of this equation, we have a charge of plus 2. On the right-hand side, we have a charge of plus 3. Which side is more positive? Of course, this side with a charge of plus 3, because plus 3 is greater than plus 2, which means we need to add a sufficient number of electrons that will make this side to be equal to this side. So how many electrons do we need to add to plus 3 to make it equal to plus 2? Of course, we need to add just 1 electron. It is just like saying 3 minus 1, which will give us 2. I'm sure you saw how that was done. So now, putting that in the equation now gives us Fe2 plus yielding Fe3 plus E minus, since we just added the electron. Now, for the other equation, we have Cr₂O₇ 2 minus plus 14H plus yielding 2Cr3 plus 7H2O. Now, let's find out the charge on the left-hand side and find out the charge on the right-hand side. On the left-hand side now, you can see there is a charge here, minus 2, right? And on this side, you can see there is a charge here, plus 1. And there are 14 atoms of hydrogen ions that own that charge. So that becomes plus 1 times 14. This now becomes minus 2 plus 14. So the charge on this other side now becomes minus 2 plus 14 gives us plus 12. On the right hand side, however, we have a charge of plus 3 here. And the number of chromium atoms that own that plus 3 is 2. So that becomes plus 3 times 2 plus, over here you can see there is no charge. This is basically neutral. This is 0. So this is plus 3 times 2 plus 0. Plus 3 times 2 gives us 6. 6 plus 0 is equal to 6. So on the left-hand side, we have 12. On the right-hand side, we have 6 or plus 6. Now, between 12 and 6, we know that 12 is greater. So how many electrons do we need to add in order to make this 12 plus 12 to be equal to plus 6? Of course, we need to add 6 electrons to make this to be equal. So therefore, the equation now becomes Cr₂O₇ 2 minus plus 14H plus 6E minus, giving us 2Cr3 plus 7H2O. I'm sure you saw how that was done. Now that we have added electrons to balance the charges, the next thing to do is to make sure that the electrons in both half reactions are equal by multiplying by an appropriate coefficient. So let's see how that can be done very quickly. So at this point now we have our two equations, the first one being Fe² plus yielding Fe³ plus, and the second one being Cr₂O₇ 2 minus plus 14H plus 6E minus yielding 2Cr3 plus 7H2O. Now, at this point now, we are adding we are multiplying to make the electrons to be equal in both half reactions. On this end, you can see we have 6 electrons, and on this end, we have just 1 electron. We want to make the electrons to be equal both on the left-hand side and on the right-hand side, or in the first equation and the second equation. So what do? We do that by simply multiplying this equation by 6, everything inside, so that this electron here can become 6 electrons. So doing that, we now have 6 Fe² plus and then 6 Fe³ plus 6E minus. And then the other equation stays basically the same. Cr₂O₇ 2 minus plus 14H plus 6E minus, giving us 2Cr3 plus 7H2O. So at this point now, all the electrons can cancel out. 6 electrons here cancel out the 6 electrons on the other side. So at this point now, we add the two half equations together. So let's do that very quickly. Now, when adding the half equations together, everything on the left-hand side in the first equation goes with everything on the left-hand side in the second equation. And everything on the right-hand side in the first equation goes with everything on the right-hand side in the second equation. So let's do that very quickly. Doing that, we have 6 Fe² plus Cr₂O₇ 2 minus plus 14H plus yielding 6 Fe³ plus 2Cr3 plus 7H2O. This is our final balanced redox reaction. This is our final balanced redox reaction. So now, at this point, we want to do a little practice. We want to find out if the charges are balanced and if the atoms on both sides are balanced. So let's check it out real quickly. All right, now, so to check if charges are balanced and to check if atoms are balanced, the first atom we have is iron. On the left-hand side, you can see over here we have 6 atoms of iron, and on the right-hand side we have 6 atoms of iron as well. So 6 left, 6 right makes iron to be balanced. The next element is chromium, or Cr. On the left-hand side, you can see we have 2 atoms of chromium, and on the right-hand side, the same thing goes. We have 2 atoms of chromium. 2 makes chromium to be balanced. The next atom or the next element is oxygen. On the left-hand side, you can see we have 7 atoms of oxygen over here. And on this side, you can see we have 1 atom of oxygen times the coefficient of 7. 1 times 7 gives us 7. So 7 also makes oxygen to be balanced. And the final atom or the final element is the element hydrogen. On the left-hand side, you can see we have 14 atoms of hydrogen. And on the right-hand side, we have 2 atoms of hydrogen here, multiplied by a coefficient of 7. 2 multiplied by 7 gives us 14. So hydrogen is 14 apiece, which makes hydrogen to be balanced as well. Now the atoms are balanced. Are the charges balanced as well? Let's check it out. Over here, you can see we have a charge of +2 on the left-hand side, +2, and then multiplied by the coefficient of 6, +2 multiplied by 6, plus, over here you can see we have a charge of -2, so we indicate that -2, then plus. Over here you can see we have a charge of +1, multiplied by the coefficient of 14, so we have +14. All of this added together gives us 2 times 6 gives us 12 minus 2 plus 14. All of this is going to be equal to 12 minus 2 gives us 10 plus 14. This is equal to plus 24. So on the left hand side, we have a charge of plus 24. Let's check out the right hand side and see what we have. So over here, we have a charge of plus 3 multiplied by the coefficient of 6 plus 3 times 6. And then over here, we have a charge of 3 or plus 3 and then multiplied by the coefficient of 2. And then over here, there are no charges basically, so it is 0. So we say plus 0. So 3 times 6 gives us 18 plus 3 times 2 gives us 6. So this is equal to 18 plus 6 gives us 24. On the right hand side, we also have a charge of plus 24. So the charges are balanced and the atoms as well are also balanced. So this is our final equation. So this, my friends, is our final balanced equation in the acidic medium. So I want to say a very big thank you if you stuck around till this point, the end of this video. If this video or this channel educated you about chemistry in a profitable way, I'd like you to do me a favor by subscribing to this YouTube channel, liking this video, smashing that notification bell icon. So when more educational stuff like this come out, you'll be the first to be notified. Until I come your way next time, my name is David, and all we do here is to take the mystery out of chemistry so chemi can make history. Till I come your way next time, please stay safe.